Hi, my name is Tom and you are at level 31 of understanding everything about Einstein's special relativity. This is the B level. I am assuming that you've seen the A level in which we let rockets going head to head. I will do a short recap, but then we will look in the space-time diagram how we can add velocities in special relativity. So here we go. So in the A level, we imagine two rockets going head to head at 80% of the speed of light. This was the setup. We are the stationary person in green. We see both rockets moving at 80% of the speed of light. They're going head to head, and our intuition will probably tell us that the person in the blue rocket will see the other rocket coming in at 1.6 C. And the same around the one in the orange brownish rocket will see the blue rocket coming in at 1.6 C, because we just add those together. This is what we do in everyday life. And then in the A level I told you, this is the right equation. And to be able to read it, you need to know about my notations. I always do it like this. The V, the velocity of something, comma, from some perspective. So the velocity between the rockets, when you are in the perspective of one of the rockets, is the velocity of rocket 1 from the stationary perspective, the S for stationary, plus the velocity of the other rocket from the stationary perspective, divided, this is where the equation goes different, by 1 plus the product of those velocities divided by c squared. And if you punch in the numbers of 80% of the speed of light, you will see that the guy or the girl in the blue rocket will see the other rocket coming in at 0.98 C, which is 98% of the speed of light, which is completely different from 1.6 C, which is the equation we would expect. So in the C level we will actually derive this equation, do the math, but now let's see it in the space-time diagram. So what I did is I built one. Here you see the URL of the website. You can just go there and play with this stuff. And we are going to move it to right now. So I need to switch screens. Let's go to this one. Yeah, there you have it. So here you have the website I just mentioned. And let me first ignore all the details. Let's first zoom in on the colored lines here. So here you see it. Yeah, it's big enough. So the purple line, I should have done green of course, is the person in green, the stationary person from the animation. That's the purple one. In the space-time diagram I always put in the rays of light, which are the green ones. And if you want to know more about space-time diagram, I have a full level on the space-time diagram. So I'm assuming you've seen that and know how to read this. And there you have it. You have rocket number 1 coming in from the left to the right, from the perspective, the purple's perspective. And in this case, I set it to 80% of the speed of light. So it just goes boom. Now here at 20 seconds, it's passing me by, and then it flies away to the right. And the other rocket is coming from the right towards me. It passes me also at 20 seconds. So these rockets go head to head, and at 20 seconds, their noses are just, in front of each other. So this is what we would see. Now let's zoom out a little bit, because I put in 2 sliders. I put in a speed slider. You can just pick it up and make the rockets go slower. Yeah, even all the way to 0. Then all the rockets are stationary in the same place. Or I can make them move faster, all the way to the speed of light. And if they are traveling at the speed of light, their slope is like 45 degrees, the same as the green lines, which are the reference lines for the speed of light. Well, let's go back to around 0.80. I'm not sure where it was. Let's zoom out. Yeah, there it is. So 0.85. So here you see speed between rockets and the stationary man in the middle is 0.8 C. This is where we start. And now the question is, how would this look like from the perspective of either rocket 1 or the perspective of rocket 2, and it's not adding those velocities. In fact, I put in a perspective slider. You can just go with your mouse, click, hold and drag, and you can drag it, your perspective, to rocket number 1. And this is what rocket 1 sees. Rocket 1 is saying, I'm not moving at all, right? All the other stuff in the universe is moving, I'm not moving at all. And what does the person in the red rocket see? He sees the purple, which is the stationary person in the chair. He said, now you are moving from the right towards me, you pass me at 20 seconds and then you fly off to the left. And that other rocket, the blue rocket, is also coming in from the right, passing me at 20 seconds and then moving away from me to the right. But if you look at the slope of the purple and the slope of the blue line, you will see that it's not 1.6 c. No, it's around, well, I did the math, so let me see. It is in this case 0.975609766, etc., c. So you see the slope is not getting steeper than the 45 reference line for the speed of light. It will never cross that, because that would mean that stuff is moving faster than the speed of light, and that's just a no-go. You can also change the perspective to rocket number 2, and then it looks like this. You see all other stuff going in this animation as well. You see time dilation, you will see length contraction, but I did whole levels on those, so I'm just going to skip over that part. But this is an easy way to play with it, and the other thing makes you play with the speed. So there you go. Well, for those brave ones who wants to know, Tom, how did you do this? How does this website work? Well, that is the great thing of this thing. It's all here. Here's the magic. You can just open it up and, no, that's hiding it. Open it up, see the equations I've used, etc., etc. So you can actually make this your own. You can just change the equations and play with them. But yeah, that's for the diehards who want to know how I built this animation. It's all there for you, free to use. So I hope you enjoyed it, and you have a little bit more understanding of adding velocities, and that if you that it will never go faster than the speed of light, no matter what you do. So let's go back to the slides. Here we go. So this is it. This is the end of the video. Here I want to point out that I made many different levels all the way from the ground up. You can pause the video and see if there's something you like. The green ones I would say are must-sees, supporting levels and optional levels. And if you scroll down all the way to level 31, we are now at 31B. And if you are a diehard, you can go to the C level, where we will actually derive the equation of that velocity going head to head. If you're not that much interested in the math, I would say go to level 32, where we will travel faster than the speed of light. Yes, we will. And it's not the same as all the other videos out there on faster than the speed of light. It will be quite different. So I hope you will enjoy that one as well. I want to thank you for watching, and I hope to see you next time.